Good morning or good afternoon, everybody. It's nice to be here. Thanks to AI and to the FreeFlyer team for inviting me to participate today. I think what I have to show you is going to be a little bit different than what has been presented so far, not so much in the guts of FreeFlyer and how to use it, but more in how I use it to support my customer base and some of the interesting things I've done with it. So without further ado, a little bit about me. Full disclosure, I'm not as independent maybe as it may seem, because before I started McKinley Aerospace, about 3 years ago now, I was actually a very proud member of the AI solution staff for about 14 years. So my history with AI, my history with FreeFlyer actually goes back quite a long ways. And when I decided to go off on my own and try to do some things, I of course did an evaluation of the kind of software I was going to need, and there were certainly options that were cheaper, all the way up to free if I wanted to use some government provided stuff. But when it came down to it, the way I like to do business, the way I like to tackle analysis and operations, it just made sense to continue to use FreeFlyer. And I hope this presentation sort of gives the group here an overview of why I think that and why I think FreeFlyer is the right tool for solving most of these problems. I do have 25 years, oh my gosh, 25 years of professional experience. It's all focused on flight dynamics, analysis and operations. I'm sort of within the flight dynamics area, sort of a jack of all trades, master of none. I've done and do navigation, trajectory, attitude. I've really kind of spanned the whole breadth and width of flight dynamics. I currently work on and have worked on a large number of different missions over the years. I started out in the shuttle and ISS worlds down here in Houston, was up in Maryland for quite some time and worked on Earth observing system and a lot of the missions that are supported at Goddard. I've done some work with geocom satellites, doing some work now on the Lunar Gateway and the power and propulsion element, J. Davis T, the Roman Space Telescope. So a really cool wide variety of missions and different orbit regimes. And for most of these, not necessarily the space shuttle because it wasn't supporting it then, but for a lot of these missions, I've always used FreeFlyer to support them. So that's shows the power of FreeFlyer there as well. And sort of my philosophy on how I approach all of this work, I kind of summarize it in this little catchphrase I have, which is from pencil and paper to splashdown. And what that means is that a good engineer needs to not be in an analysis bucket or in an operations bucket, but really sort of look at the problem of flying a spacecraft from start to finish, and need to be able to do everything from write down some equations on a piece of paper all the way through flying that spacecraft and all the steps that go in between, which is the analysis and the operations. And I firmly believe that there are organizations out there that tend to segregate analysis and operations, and I think that's very inefficient. I think the new space kind of companies are getting much better at recognizing that it's a continuum and not to put those things into buckets. The government maybe not so much in terms of how they organize their centers and some of their projects, but I really firmly believe that they are part of one activity and should be treated that way. And what something like FreeFlyer allows you to do is to start your analysis in one piece of software and continue to build it and tailor it and essentially fly the spacecraft with the same piece of software that you were doing your analysis on. And so having to implement this sort of pencil and paper to splashdown methodology, you really do need good software and good people who understand how to solve those problems. So I'm going to show this presentation is mostly about the UI generator, and we'll show a couple other things that we built to demonstrate that generator. I want to talk a little bit about what motivated me to build this thing. And it was really one of the first things I built when I started the company. And I had been working on a large-scale flight dynamics system that did use FreeFlyer as its computational engine, but it had some very, very stringent UI design requirements. It was essentially a refresh of a legacy system, and there were even requirements where they wanted the new UIs to look exactly like the old UIs. From a training point of view, I guess that makes sense. To not have to retrain on UIs and things like that. But the requirements were what the requirements were. Certainly, FreeFlyer's native UI capability couldn't meet those sort of stringent requirements, and so they had chosen another language to go develop UIs in and then interface to FreeFlyer. As I worked this project, and I noticed as it went along, significantly more time and effort was being placed into the design of the UIs and the implementation of the UIs than it was into the actual flight dynamics algorithms. And it was a group of mostly flight dynamics analysts, and so that was kind of a head scratcher. You've got these folks who are really smart at flight dynamics, and they're being bogged down by designing and implementing UIs in a very particular manner in a language that most of them had to learn from scratch in order to do the implementation. So I thought there was probably a middle ground somewhere between FreeFlyer's existing capability and going out and getting a third-party language and writing your own UIs from scratch. There should be a middle ground there, and that's what I attempted to come up with. Because one of the other sort of points about this is I think it was Cody's presentation a few days ago where he talked about how great FreeFlyer's features are in terms of interfacing with different systems and other languages and things like that. Well, that's great for somebody who's smart like Cody. For me, I want to use FreeFlyer. I want to do everything I can inside of FreeFlyer and not have to go and learn other languages. And not that I can't, obviously, but I want to implement everything I can inside of FreeFlyer because FreeFlyer is the tool I've chosen to do all of this work in. And so I'm going to find as much capability inside of FreeFlyer so they don't have to routinely go out and interface with any of those other languages. So I developed this thing that I call the UI Generator. Even though I just said I want to do everything inside of FreeFlyer, it is actually a JavaFX app. It had to be because the overall capability that I wanted wasn't necessarily inside of FreeFlyer. So I had to develop it outside of that. So it is a JavaFX application that interfaces to FreeFlyer through the API. You can launch mission plans via the UI Generator. So you just, we'll see in the demo here in a few minutes, you just click the mission plan you want to run and you run it. You can add mission plans and remove mission plans from the application through a simple drag and drop process. This is the key that I wanted to achieve with this, was that the full UI layout, it's all defined inside the FreeFlyer script. So just like the entire, if you were to use FreeFlyer's native UI capability, that's all done within the FreeFlyer script. I wanted to maintain that capability, but give, again, more flexibility. So I think we were able to achieve that. So the user never has to really go and touch the JavaFX code. They simply run the application, launch their mission plans through the application, and define all of the layout of the UI inside of FreeFlyer's freeform script. You can have as many UIs inside a mission plan as you want. You can maintain persistence of your inputs. It's actually a very simple thing. We'll show how we actually link each of the control objects in the UI to a FreeFlyer variable. So when the UI is drawn for the first time, whatever the value of that variable is at the time at that point in the mission plan, that'll be the value that shows up in the UI. So you can maintain persistence. You can easily skin them with CSS style sheets. I think there was a lot of discussion during Sarah's presentation about dark mode for FreeFlyer itself. I also am partial to dark mode. And so I really like being able to play around with the CSS and get the different looks that I want. There's a lot of ways to get data through the UI Generator, a couple different ways to get data out of a mission plan and look at it. You can actually choose to show the entire FreeFlyer workspace if you want. So just as you would click run on a mission plan and see the output, you can certainly see all of that output. You can also unconstrain any of the FreeFlyer objects, so plots, view windows, watch windows, console. I'll even show a demonstration here where I unconstrain the console. So any of those that you can unconstrain from the workspace, you can actually pop up individually as you run through the mission plan. And then there's also a dedicated text output window where you can have the mission plan actually format a bunch of output data and then just send it to this window to look at. What controls are available? So it's the standard set of things you would expect to see in any sort of UI. Everything is sort of grouped as a panel, or is created as a panel, and what a panel is, or what I've defined a panel as, is some kind of a control, like a text box or a combo box or a text input or radio button. But then I group that with a label. So it's very easy. You don't have to separately place a label and then the control as you would in a higher level UI language. You just specify that, I want a combo box, I want it to be labeled sequence, and I want it to have these options. So there's all those panels. There is also a capability to implement your own custom UI controls. So you can I've developed a JavaFX class that you can extend, and there's an interface, and as long as you follow that interface, you can actually then import custom JavaFX controls into the UI as well. And the reason for that is, and I'll show a live example here of this in a minute. But if you need some sort of dynamic behavior on your control, so when I pick a different ground site here, I want to update the information at the bottom. That wasn't very simple to achieve just with basic controls and have that done in real time. So that's why I developed a custom control for something like that. So how do I run a mission? How do I implement a UI and run it? So all of the mission plans that you're going to run through the UI actually have to conform to a template, because the template will actually define certain API labels. So that as we're interfacing to the API through the API to FreeFlyer, the application knows where to stop at certain points, and at those points, it reads variables and understands how to build the UI and then continue. It defines certain variables that need to be defined for all of the UIs. So there's a variable number of UIs, pretty self-explanatory. Tells you how many UIs are going to be in the mission plan, and then all of the actual definition of a control is contained in a string array called GUI data. Just very straightforward. So every time I want to define a new UI, I have to populate this string array called GUI data with the sort of pseudo markup language that we'll take a look at next. And each of the control definitions generally consists of just a few different variables and things that define it. So there's a keyword, which basically says what kind of control do I want to make. I give it a mapping to an existing FreeFlyer variable. So right now I've limited that to strings. Any numeric values or things like that, I actually convert from the string to use inside the mission plan. There's some text that'll define the label that'll go along with the control. You can adjust the height and width. You can adjust the placement of the control on the UI itself. So the UI actually has a very simple flow. It's a very simple grid flow, and you just tell it, within that grid, what row and column do I want to place this control in, and then you can actually also span over multiple rows and columns. Very similar to how FreeFlyer's grid window works. And then some justification information, so you can actually shift where you want the label to be justified, relative, left, center, right, inside of its label space. So a little bit more of the implementation example. So what would it look like to define a control inside the mission plan? You can see here, this is that GUI data string array, and I'm just adding a string to it. And that string says essentially that I want a combo box panel. I'm going to link that to the FreeFlyer variable model type. The label is going to actually say model type. And because it's a combo box, I have to give it some options. So here's a string delimited by the ampersand sign, or the percent sign, and the two variables two values that'll be in the combo box are static and dynamic. And then the label width, the combo box width, and then where I want to put it on the grid, how many rows and columns I want it to span on the grid, and then where I want the justification to be. So for every control I want to add to the UI, I just simply create a string like this. There are additional utility keywords that we can add to this GUI data array to control some other things. There's a size keyword, which basically lets me specify the overall size of the UI in terms of height and width. Excuse me. And then there's a grid gaps setting, and essentially all that does is it creates space between the different grid elements on the UI. So if I want to create space between my controls on the UI, I've got a little bit of a control or a little bit of a way to do that. So we'll look at a demo here in a second, but this is what the UI generator looks like. This top area here is actually the UI generator controls, and I'll run through how that works here in a second. But everything below here is actually the UI that I've defined using the code here on the left. So you can see I'm just adding combo box panels, file selector panels, text panels, and I'm just placing them where I want them on the UI. Pretty straightforward. Another example, this is an example of actually using the custom libraries. So most of these panels in here are actually custom controls, and you can see right here, what I do is I define a custom, and then I just give it a Java class that holds that control, and that Java class extends the custom JavaFX class and conforms to the interface that's been defined. So it knows how to use that information. So you do end up having to do more code in another, or more programming in another language, but it is a way to actually extend a little bit more flexibility to what's going on. Okay, let's take a real quick look at the demo. So I'm just going to launch the UI generator. When it starts, it just comes up like this. The mission plans that I have in the generator right now, I have 3 of them: an attitude design mission plan, a contacts mission plan, and this SRP drag area mission plan. Very simply, if I wanted to remove this mission plan, I can just drag it over to the wastebasket and it goes away. I want to add it back in, I just go to where the mission plan is located, drag it up here, it gets added back in. So what I do is I come in and I have a couple of controls. First, I can select the mission plan I want to run, and then there's a button that will then execute that mission plan. There's a stop button that quite honestly doesn't do anything right now. That's for future implementation. But then there's also a restart button. And what the restart button does is from time to time, you can get into a situation where the mission plan hangs up or the mission plan stalls. Not necessarily because the UI generator is doing anything bad. You could have an error inside the mission plan. It happens from time to time when you're interfacing through the API. So this restart button will actually shut down the FreeFlyer engine and restart it. So when I want to run an application, I just hit run. And it launches that mission plan, it reads through the mission plan and goes to where the UI is defined and creates that UI. So this, I think folks may find this interesting because there was a lot of discussion about flat plate SRP modeling earlier on in the week. And this application is actually takes 3D models inside, well, an ASCII version of 3D models that FreeFlyer can read. It's an STL format. But instead of just using the model object, it actually reads in the entire array of triangles that defines that model, and will then do a bunch of stuff to essentially determine whether each of the triangles in that model are visible or shaded from either the sun or the velocity vector. So you can use this to essentially compute the frontal area for SRP or drag analysis, and it's all done inside of FreeFlyer. I think it's pretty cool. But so what I'm going to do is we'll look at a dynamic model of Aqua, and what this will do is it'll propagate between these 2 times, and at every time step it'll actually do the calculations of shadowing for Aqua and rotate the solar array. And that's the reason it's a dynamic model, is it'll rotate the solar array as it should. Some of this region of interest information, the UI is there, that's functionality that's not implemented yet. So when you're ready to run, you hit next, and here this pops up an unconstrained console window, and it's reading and doing the calculations on all these triangles within the model. And then when it's done, it pops up a window. And so what we'll see here, the red is where you're actually hitting the velocity vector, and the sort of bluish gray is hidden from the velocity vector. So as the array rotates around, we'll see it eventually goes out of the surface of the array eventually goes out of view of the velocity vector. And the color is actually scaled to essentially the cosine of the normal vector to that velocity. So it went through a couple of time steps there and calculated the frontal area. So we can see all the red on the front of the spacecraft because it's hitting the velocity vector. The backside is obviously not seeing the velocity vector, and it will do a calculation of the area. And there's a little joke in here, meters squared, I think. It's just the model file I'm using actually doesn't have a units assigned to it, so there's some scaling I need to remember to go back into when using these models. So you can do that for the velocity vector. You can also do that for the sun vector. I'll go through and calculate it again. And this time we'll see as the array rotates, as you'd expect, it rotates with the sun. So the array always stays sunlit. But now we start seeing shadow and sunlight features show up on the top of the spacecraft, which is kind of cool. And obviously the side away from the sun is permanently in shadow. So it's just a real cool tool that does some kind of neat things. But shows, you can, through the UI generator, you can output, a console window to get information. Here we're showing a 3D view that's unconstrained. Another application I'm going to run is this attitude design. This is actually meant to mimic one of the more complicated UIs that that project I had referred to earlier always wanted and always had to be the same. So this UI actually has two UIs in it, or this mission plan has two UIs in it. The first we check them, we select a mode, hit next, then we get the UI for that mode, and we can hit next, and we'll go through do some calculations. And here, this is the text output. So FreeFlyer computes all this text and then just sends it back to the UI to display. And then this also has a 3D window that shows the attitude of the vehicle and some different pointing vector information and coordinate systems and the like. But one of the neat things you can also do with the UI generator is if I select an option here at this UI and I hit next, and it brings up the display, and like, oh no, it's not the right mode, I need to go back. I can simply go back and choose the right mode and run that. Also have an option here if I want to keep this output to compare to the next run. I just click new output window, and instead of redrawing, it actually gives me new output windows. There is a message window here at the bottom, which essentially just gives me different information. I've started a mission plan, I've completed the mission plan, I'm waiting on, I'm waiting on user input, that sort of information. Error messages when FreeFlyer errors out will also show up here. If I were to restart the FreeFlyer engine, it'll actually tell me it's restarting the FreeFlyer engine. So that's a real quick demo of the capability. And future work, what would I like to do in addition to this, or what would I like to add to this tool? So the latest release of FreeFlyer actually has a new diagnostics object that I think can smooth out some of the mission plan error handling and reduce the number of times that you get the engine hung and have to restart it. So I'm looking forward to implementing that object in the back end and smoother handling of errors and smoother reporting of errors. Some of the data directories and things and the ways I have this configured is a little kludgy right now, so I need to clean that up and make that a little bit more user-friendly. And I'm also looking at a way to do a dockable or layered output approach. As you saw, when I would run things, windows just sort of popped up in different places and things like that, which isn't that big a deal. But I have some ideas about actually docking those or layering them in a window. And this is where I'll start putting in my plugs for things I want to see in FreeFlyer. And I know this has been talked about in the past, but the ability to take some of those unconstrained objects and embed them into other window applications. would be super powerful for this kind of a tool. And I'd really like to see that. So I'll end by just expounding on what I think of FreeFlyer. And is it perfect? Of course not. But I do think it is the most capable flight dynamics software for the things that I want to do. And there's a reason I've invested in it on my own versus going with free options from the government or something like that. It really is that much more powerful than a lot of the other options. So Sarah only let me input one of the things I would like to see in her little presentation a few days ago. So here's a whole list of things I want to see. And maybe some of these are self-serving and things like that, but they are what they are. So I would really like the ability to save and reload output workspaces. So I do a lot of Monte Carlos. I do a lot of analyses that take a long time to run. And sure, I can always save off the stuff that's important in the results and things like that. But if I could just save the output and then and granted, it's probably going to be a huge file, but then go back into FreeFlyer and reload that output file and get the output workspace as it would look as if I had just ran the mission plan. I think that would be very powerful because I like to use the output workspace as a place that I store results and how I look at results, and I'm very used to that. The user-defined measurement models, very happy to see that in the stack of things that you guys want to look at. I think I've been an advocate for those for quite some time. I will just put my little plug in here. I'd love it if I didn't have to do that through an extension. If there was some way to do it just in freeform scripts without having to go through an extension. I don't know how you're planning on doing it, but if you're taking votes, I'd rather not open up another piece of software. I'd rather do it all in FreeFlyer. I'd really like to have access to the integrators somehow, just like in MATLAB, where I can specify an M file that holds some equations in motion and then integrate them. I think it'd be cool to be able to do something very similar, have that level of access to the integrators in FreeFlyer. And then some non-API, so other than going through the API to do multi-threading, it'd be cool to be able to do that natively. And I think Michael Volley's been working on some hacks and things that maybe you're able to do that. But if I have a loop of 1,000 iterations of something I'm doing on a Monte Carlo trial, it'd be cool to be able to say, okay, spread those 1,000 things across 4 processors or 8 processors or whatever the number is. Something like that inside of FreeFlyer would be very cool. But it's really close to perfect. Don't get me wrong. I'm not complaining. That's it. That's my little demo, my little spiel, and I hope folks found it interesting. And thanks again to the FreeFlyer folks and AI Solutions for giving me this opportunity.
Hey, Dave, thank you so much for this demo. Honestly, this is such a cool demo. The FreeFlyer team was watching you, and we're very excited and impressed by the power of this UI. I think we all can testify to that. So we have a few questions for you. I know we're running short on time, but I hope we can spare a few minutes for them.
Oh, cool.
First of all, can somebody get an evaluation license of this UI? What is the contact information?
Yeah, so if anybody would like to look at it, just shoot me an email. I haven't thought of a scheme for licensing it or even giving it away. I don't have an answer to that yet, but I'm also not looking to hoard this either. If folks are really interested in using it, we'll find out a way to get it to them.
Okay, so contact you and figure it out.
Yeah.
Awesome. So we have some technical stuff here. Are you using FreeFlyer extensions at all?
In any of the things I just showed you, no, I'm not using FreeFlyer extensions. I have used them in the past, and I've written extensions, but anytime I don't have to, I prefer not to.
Yeah, that makes sense.
But nothing I showed here used an extension.
All right. So we're very curious, how did you color code the parts of the 3D model red or blue in that demo that you showed?
So yeah, that's actually pretty cool. So this will get a little bit technical, and I hope I do it justice. But the 3D model is encoded as a series of triangles, and what I do is I have a routine that essentially creates a vector from the center of every triangle, and I do the intersection of that vector with the actual 3D model. And if the vector intersects, that means the piece is shadowed, and I color code it red, or I think red. And then if it's not, if the vector doesn't intersect, then it's green because it's open. So it's really that simple. There's some logic in there that you can actually specify. You can take the big triangles and actually break them up into smaller triangles based on an area limit. So you can actually get really good refinement in terms of, you may have seen some of the models looked a little jagged in terms of the transitions, but you can actually narrow that down quite a bit. And it just takes more computation time in order to do that.
Yeah, but it seems pretty straightforward. I mean, thank you for.
And I think somebody asked the question a few days ago, can you do that? Anytime the sentence starts, can you do this in FreeFlyer? The answer should always be yes, because I'm sure there's a way to do it.
You're spot on here. So how did you do self-shadowing as well?
Sorry, please?
How did you do self-shadowing in the mission plan that you showed?
Sure, and it's actually just what I described is I create that vector from the center of the triangle, which is just a piece of the model, and then I do the vector intersection between that vector and the actual 3D model itself. Does that make sense?
I mean, that makes a lot of sense, yeah. So we have a message from the development team, specifically from Sarah, and they want to tell you that we really appreciate your feedback for these requests, and we have them in mind, and we have plans that are very similar to what you asked for, and these reaching out to you for beta testing in the not too distant future. So our team will be following up with you to to get in these new features that you mentioned, because that will make the UI even more powerful, as you mentioned.
Good.